Hello everyone, and welcome to the online classes of TPS Syllabus. Let me begin by introducing myself. I'm Nandita Das ma'am, and I have been assigned to take your chemistry classes for this week. Before I begin, I want to share a message with you. In this situation where every one of us are locked up in our homes, I hope that all of you are safe. And even in this situation, all your teachers are trying really hard that you still keep learning. So please acknowledge this fact and utilize your time effectively. Okay? So let's begin with the chapter. Now, the chapter that I have chosen is Solutions. Solutions is the second unit of your Part 1 book. All of you are very well aware that what is a solution. If I ask you what is a solution, you will immediately come up with the answer that, ma'am, solutions are made up of two components, that is solute and solvent. This is what you have learned in your junior classes, right? Now, when you tell me that your solution is made up of solute and solvent, that means your solution is a binary solution. But did you learn beyond that? No. This is why we have to learn. This is what we will learn in this chapter. Okay? Now, when we talk about solutions are of different types. I've written the types on the board and I'll explain each of them in detail. Okay? The first type is gaseous solutions. Now, when we talk about gaseous solutions, I've written solute and solvent. When we choose, my solvent is something which is present in larger amount and solute is something which is present in lesser quantity. So if you dissolve gas in gas, that will be known as a gaseous solution. And an example for this category would be nitrogen gas dissolved in air, okay, or oxygen gas dissolved in air. Second, liquid in gas. Let's take the example of moisture dissolved in air. Third, solid dissolved in gas, like dust particles dissolved in air. You can also take the example of naphthalene dissolved in air. So this is about gaseous solutions. Let's go to liquid solutions. That means my solvent should be liquid. Gas dissolved in liquid. Example is oxygen gas dissolved in water. Okay, with the help of which we all know aquatic animals survive. Okay, next, liquid in liquid. Common example is ethanol dissolved in water. Next, solid in liquid. Salt dissolved in water. So we're done with liquid solutions. Let's come to the last category, that is solid solutions. That means my solvent should be solid. Okay, now this is something that is new for you. This are something that you observe almost every time. Let's discuss about this. Gas dissolved in solid. An example of this is hydrogen gas dissolved in a metal like palladium. You can also choose platinum or nickel. We call this the phenomena of adsorption. Now this phenomena of adsorption you will learn in detail in Unit 5. Okay, so there's an entire chapter about adsorption. So where you will learn about this in detail. So just remember the example that hydrogen dissolved in metal like platinum, palladium or nickel. Okay. Next, liquid in solid. Example, mercury is a liquid metal dissolved in sodium, that is solid. Now, this will give me a class of compounds which are known as amalgams. All of you are familiar with the term amalgams because alloys of mercury are known as amalgams. Both of them are metals, so The example for liquid and solid is amalgam. Last, solid in solid. Example, copper dissolved in gold. Solid in solid. We get alloys. So, with this, I'll conclude my discussion about the different types of solutions. And before we go to the next topic, I would like to give you a small information that whenever we talk about solutions, you have to remember one thing. Solutions are made in solvent. Now there are different types of solvents. When we choose water as a solvent, that kind of solution will be called aqueous solutions. Okay? And when we choose any other solvent, organic solvent like benzene, ether, CCl4, okay, or other solvents other than water, in that case, your solutions will be called non-aqueous solutions. Okay, so I hope this much is clear. So we have discussed about types of solutions and we have discussed about aqueous and non-aqueous solutions. So we'll go to the next topic. Now what is the next topic? The next topic is concentration of solutions. Concentration of solutions. Now, what is the meaning of the term concentration? When you prepare a solution, you add certain quantity of solute to your solvent. The amount that you add determines your concentration. Some solutions are dilute, some are highly concentrated. You have learned different methods, okay, of determining the concentration of solutions in class 11. Like you have studied about mass percentage, you have studied about volume percentage, you have studied about molarity, mole fraction. All these, formulas you have learned in class 11. So it's the same thing here. We will just do a brief revision. So mass percentage and volume percentage are easy, so I'll not do that now. I'll give you the formula. When I'll give you an assignment, I'll write that formula in that, in that assignment note. And definitely I'll give you examples and numericals which you will have to solve. But I want to discuss molarity, and mole fraction in detail. Let's start with the first one. Let's do molarity. What was the formula of molarity? Number of moles of solute by volume of solution in liters. Okay? Number of moles of solute by volume of solution in liters. That means if we talk about 1 molar solution, because I hope you remember molarity is given by capital letter M. When we talk about 1 molar solution, that means 1 mole of your solute is dissolved and the solution is made up to 1 liter. If you talk about 1 molar solution. Let's take an example of a numerical. Okay? Alright. I'll solve the numerical for you. I'll read out the question. 2.46 gram of sodium hydroxide. 2.46 gram. 2.46 gram of NaOH are dissolved in water and the solution made up to 100 centimeter cube. Solution is made up to 100 centimeter cube. In a volumetric flask, calculate the molarity of the solution. So, according to the question, my given mass we will write as Wb. Wb is equal to 2.46 gram of NaOH and the solution's volume is 100 centimeter cube. Now, for molarity, It is number of moles by volume of solution in liters. Okay. Now to find out the number of moles, I hope all of you remember the formula is given mass by molar mass. Given mass is 2.46 gram. We will separately calculate the molar mass of NaOH. NaOH 23 for sodium, 16 plus 1. It comes to 40. So 2.46 by 40. This, if you calculate, you will get around 0.0615 moles. Okay, so I have got my number of moles. So molarity is equal to 0.0615 divided by the solution's volume was 100 centimeter cube, that is 100 ml. I need to convert it into liters, so I'll have to divide it by 1000. What I'll do is I'll simply take it here and multiply it. My result is 0.615 mole per liter. Okay, this is your answer. So I'll be giving you numericals relating molarity in the assignment. Next. Molarity. The next topic is molarity. When we talk about molarity, we must remember that it is given by the symbol small letter m. The molarity is number of moles of solute by mass of solvent in kg. Number of moles of solute by mass of solvent in kg. Let's solve the numerical. Okay. I have one here. It says calculate the molarity of a solution containing 20.7 gram of potassium carbonate. Okay, so given mass is 20.7 gram of potassium carbonate dissolved in 500 ml of solution. Volume is 500 ml of solution. Assume the density of the solution to be, one additional information is given to you. Density is 1 gram per ml. Density is 1 gram per ml. So first task, we need to find the number of moles. So number of moles is given mass by molar mass. So that is 20.7 divided by K2CO3. Potassium is 39 into 2 plus carbon is 12 plus 3 into 16. This comes to 138 gram per mole. Okay, so I'll have to divide this. If you calculate this, this will come to 0.15. Okay, so we have got the number of moles. Now, you have to remember that for molarity, we need to find the mass of solvent, but volume of solution is given. Volume is given, density is given. We know that density is equal to mass into volume. So, density is mass into volume. Density is equal to mass by volume. So, mass will be density into volume. So, density is 1 into 500. So, my mass comes out to be 500 grams. So, the mass of the solution is 500 grams. This is of solution. I need to find a solvent. So, if you need to find a solvent, so mass of solvent will be 500 minus the amount of solute that you have added. You have added 20.7 gram of solute. If you subtract this, you will get 479.3 grams. So this is your mass of solvent. Let's calculate the molarity quickly. molality will be 0.15 divided by 479.3 into 1000. Remember, this was in gram, we need to convert it into kg. If you calculate this, you will get 0.313 molar. That is mole per kg. Okay, so this is how you will solve numericals based on molality. Alright, next, let us discuss about mole fraction. Now, mole fraction. Now, what is mole fraction? Mole fraction, if you have a solution which consists of two components, A and B. Let Na be the number of moles of A and Nb be the number of moles of B. Okay? Now, mole fraction is given by the symbol chi. So, mole fraction of A will be number of moles of A divided by number of moles of A plus number of moles of B. Similarly, chi B will be number of moles of B divided by number of moles of A plus number of moles of B. So, this is the formula. Additionally, you should always remember that chi A plus chi B. That means the mole fraction of the solution is equal to 1. And chi A is equal to 1 minus chi B. These are the relations that you will use in numericals. Okay? Let's find out. I'll give you one small example. Okay? One small example. There's a question here which says that the mole fraction of ethylene glycol. Now, ethylene glycol is C2H6O2. C2H6O2 in a solution containing 20% by mass of ethylene glycol. 20% by mass of ethylene glycol is your solution. Now, by mass, if they say, that means your solution contains 20 grams of ethylene glycol and 80 grams. That means the rest is water. So this becomes your given mass. Find out the molar mass of ethylene glycol and you can easily find out the number of moles. Okay. Once you find out the number of moles, you can calculate the mole fraction. So I will give you numericals related to this also. Okay. Now, so these are a few methods which I wanted to discuss regarding concentration of solutions. Next, after this we will discuss about solubility. Solubility. Now, what is the definition of solubility? Solubility is the maximum amount, solubility of a substance is the maximum amount that you can dissolve in a particular amount of solvent at a particular temperature. Solubility of a substance is the maximum amount that you can dissolve in a particular amount of solvent at a particular temperature. Now, when you talk about solutions, we will be discussing about dissolving solids in liquids and dissolving gases in liquids. Solids in liquids, that means we will discuss about solid solutions, liquid solutions. Okay. Now, when we discuss about solubility, we have to think about two factors which will determine or which will affect solubility: temperature and pressure. Okay, let's start. So let's first start about solid in liquid. Okay, now when we discuss about solubility of solid in liquid, I'll take examples of two compounds. One is common salt and the other is naphthalene. or you all prepare this solution almost every day. And you observe that salt is very easily soluble in water. But if you try dissolving naphthalene in water, it is almost practically impossible. Why is this so? This is because water is a polar solvent. Water is a polar solvent and salt is an ionic compound. That means that is also polar. So we have to remember the rule that like dissolves in like. Okay? So salt will dissolve in water because it has got polar nature and water has also got a polar nature. At the same time, naphthalene is an organic compound and it will dissolve in organic solvents like benzene. So we will go by the rule like dissolves in like. Okay, next. When you dissolve a solute in a solvent and you prepare a solution. Okay, when you dissolve a solute in a solvent and you prepare a solution, there is a process that when the solute goes into the solvent, that process is known as dissolution. That process is known as dissolution. Okay? And at the same time, some of the solid solute particles are coming from the solution into the solid state. That process is known as crystallization. That process is crystallization. So when these two processes are at equilibrium, you cannot dissolve any more solute into your solution. At that stage, your solution will be called a saturated solution. That will be called a saturated solution. And all of you know what is a saturated solution. A saturated solution is one in which no more solute can be dissolved. Okay, that means in which rate of dissolution and rate of crystallization are same, are at equilibrium. The processes are at equilibrium. Now, when we prepare a solution, we observe changes in energy. That means if I write here delta H is positive, delta H is positive, that means your process is endothermic. Your process is endothermic. Now, how does temperature affect this kind of a system? If you increase the temperature, solubility of the solute will increase. Okay, if the process is endothermic, solubility of your solute will increase. And if the process is exothermic, the solubility will decrease. This is what you have learned in class 11. This is according to Le-Chatelier's principle. Okay, so this is how temperature affects solubility. If we talk about pressure, pressure hardly has any significant role to play in solubility of solids in liquids because solids are highly incompressible. So normally solid solutions are prepared in atmospheric pressure, so pressure does not significantly affect this kind of solutions. Okay, so this category is done. Next, let's discuss about solubility of gas in liquid. Okay, now this is a very interesting topic and this is where you need to focus more. Okay, gas in liquid. Okay, let us take a system. I've taken some amount of solvent. I've closed this system. Okay, and there are some gas particles here. Okay, now you know that the gas particles will enter and some of the gas particles will leave. This is now due to evaporation, some vapors will develop here. Now, if you increase the pressure, it is very much understood that more number of gas particles will be entering into the solution. More number of gas particles will be entering into the solution. Now, this relationship was very nicely explained by Henry. And he gave a quantitative relationship. What did he say? He said that the partial pressure of the gas in the vapor phase is directly proportional to the mole fraction of the gas in the solution. The partial pressure of the gas in the vapor phase is directly proportional to the mole fraction of the gas in the solution. Now, he replaces proportionality sign with a constant, that is Kh. Now, what is Kh? Kh is known as the Henry's law constant. Kh is known as the Henry's law constant. Now, different gases. We have different gases around us, and different gases have different values of Kh. Also, you must remember that the solubility of all gases in a particular liquid or in a particular solvent is not the same. For those gases whose Kh value is high, the solubility of that particular gas is low. So, higher the value of Kh, lower is the solubility. Is that clear? So, there is a table in your NCERT. In that table, different gases are mentioned and their Kh values are written. So, you go through that table. Okay, it will help you to understand better. So, this is the Henry's law statement, Henry's law relation. It's very, very important. The next part that we need to do or need to learn from Henry's law is the application of Henry's law. Now, what are the applications of Henry's law? How can we utilize this in our day-to-day lives? All of you have, you love to drink cold drinks. And when you open the cold drinks bottle, you observe that gas bubbles, fizz out. Why is that happening? In your cold drinks bottle, carbon dioxide is sealed under high pressure. So that its solubility increases. When you open the cap, the pressure is released, and all the gas, oozes out, and until and unless there is an equilibrium which is established between the atmospheric pressure and the gas in the solution, it starts fizzing out, and after some time it will fall flat. So that is one application. Second application, and the most important one that you should learn in detail, is about bends. It is about bends. Okay? Now, what is bends? All of you know what is scuba diving. The scuba divers, they carry an oxygen cylinder with them. Now, in that oxygen cylinder, they have oxygen, they have nitrogen. Okay? And there is a mixture of helium also. Now, why do they mix helium in that mixture? Is because the solubility of nitrogen in the blood is very, very high. When the diver goes down, the pressure increases. Okay, when the diver goes down, the pressure increases and the solubility of nitrogen in the blood increases. When the diver is coming up to the surface, the pressure decreases and nitrogen gas bubbles might, get blocked in the capillaries of blood and they will form bubbles. This will restrict the blood flow. And this leads to a painful condition which is known as bends. To avoid this, helium is mixed in the oxygen gas cylinders, and that mixture is known as trimax. Okay, and why is helium mixed? Because the solubility of helium in blood is low. So learn about bends in detail. Alright, the last that I want to discuss is anoxia. Now, what is anoxia? All of us have traveled to hill stations, and when we go to very high altitudes, it is said that if you are not suffering from any respiratory problems, you should avoid going to high altitudes because the concentration of oxygen at high altitudes is very, very less. Now, the higher you go, the concentration of gases starts to reduce. So in that case, you start, breathing in less oxygen, and the amount of oxygen that reaches your brain is less. So your thinking capacity reduces. This condition is known as anoxia. So these are the applications of Henry's law which you should learn. Prepare detailed notes about this because your question papers nowadays are mostly application based. And every year, if you pick up any board question paper, you will see every year one question from this section has been asked. Okay? So I'll stop discussing about Henry's law here. And with this, I will conclude my lecture today. The next day, we will start with vapor pressure of liquid solutions. So in today's class, we have learned about types of solutions. We have learned about methods of finding concentrations of solutions, and we have learned Henry's law. So you will have to solve assignments relating to this. Okay? Thank you, everyone.